Heat pipes are used to move heat from one location to another. When one end is heated, the water inside it heats up. Once the water reaches a boiling temperature, it turns into a vapor. This vapor then moves to the other side of the pipe, where it is cooled until it condenses. The condensed water then travels through the wick back to the other side, where the water is again reheated until it boils. We know that water takes more energy to heat up when there is a larger mass, because the boiling point rises when there is higher pressure. Since the water needs to boil, our hypothesis is that less liquid equals a lower pressure, and therefore a lower boiling point, which will make the heat pipe more effective. However, there still needs to be enough water in order to efficiently transfer heat in the pipe. When making the heat pipes, we first measured that they contained 49 milliliters of water. Then we made 8 heat pipes, each one filled with 0 to 70% and 100% water. All the other components of the heat pipes were the same. However, heat pipes do not contain air inside, only the working fluid. To get rid of the air, we would boil the water at the bottom of the heat pipe. The steam then rises and pushes the air out above it. When steam started emerging from the opening, we would close the heat pipe with a cap. Since we needed to test how well our heat pipes transferred heat into another material, we needed to have another object at the other end of the heat source. To solve this problem, we attached a styrofoam cup to the other end of the heat pipe, which would be filled with 25 milliliters of water, enough to fully submerge the tip of the pipe. However, we noticed that our heat pipe gradually got cooler as it moved away from the heater. Therefore, we insulated our heat pipes by wrapping styrofoam cups around the middle. This insulation reduced the amount of heat lost before reaching the water. Our goal was to compare the amount of heat in the water to the amount emitted from the flexible heater. We recorded the energy that went into the heat pipe and the temperature of the water. In order to see any change, we let the experiments run for 15 minutes to get enough data. We then converted the temperature of the water into heat energy.